Improper integrals, we've already really seen one or two of them on your exercises, and we mentioned them a little bit briefly. I'm just going to go through them more carefully and more systematically now, and we want to get just exactly what's going on with these rates of decay and their relationship with improper integrals. So I need to understand, for you to understand on the spectrum of the range of functions like this, which ones are suitable for integration as x goes to infinity. Well, let's start out with the definition. The integral from a to infinity of f of x dx is by definition the limit as n goes to infinity of the ordinary definite integral up to some fixed finite level. And that's the definition. And there's a word that we use here, which is that we say the integral, so this is terminology for it, converges if the limit exists and diverges if not. Well, these are the key words for today. So here's the issue that we're going to be addressing, which is whether the limit exists or not. In other words, whether the integral converges or diverges. These notions have a geometric analog, which you should always be thinking of at the same time in the back of your head. I'll draw a picture of the function. Here it's starting out at a, and maybe it's going down like this, and it's interpreting it geometrically. This would only work if f is positive. Then the convergent case is the case where the area is finite. So the total area is finite under this curve. And the other case is the total area is infinite. Now, I claim that both of these things are possible. Although this thing goes on forever, right? If you stop it at one stage n, then of course it's a finite number. But as you go further and further and further, there's more and more and more area. And there are two possibilities. Either as you go all the way out here to infinity, the total that you get adds up to a finite total, or else maybe there's infinitely much. For instance, if it's a straight line going across, there's clearly infinitely much area underneath.